Okay, now I'm going to start the timer. Welcome, everyone. Thank you for being here. We're here to discuss Universal Safety Technologies and their Salesforce implementation project. They're a provider of safety and security systems to commercial customers in the US and Canada. Their main processes are sales, design, installation, maintenance, monitoring, and service. That is their life cycle. The primary pain point is they have siloed systems, which is leading to more work for employees. And their goal is to create more efficient processes to better protect people, property, and assets from fire and theft. Some broad assumptions: data secure by default, both at rest and in transit, buy before build, an MVP approach, and that the design tool that exists in their landscape can be modified and also can initiate an integration. My org strategy is single org. There's no explicit compliance requirement for data residency. There's unified global business process. We can fit within the limits, the governor limits of a single org. This will make a single view of CRM data easier, and collaboration across all of that data and reporting across all that, and operational reports as well. And it'll minimize our integration effort required for this project, which has a 4-month delivery goal. So that is the reason for our MVP approach. We'll also be using multi-currency, multi-language, more to come on that. The actors involved internally will be the system specialist, support rep, and managers at various levels. The system specialists will have Sales Cloud. They'll be working with the order object. Support rep will have Service Cloud due to the need for Service Cloud voice and omnichannel. The managers will have Sales Cloud and Tableau CRM. They report on sales activity and use advanced analytics. The contractors, so externally now, with contractors, they will have the CC license. They don't have a need for advanced sharing or reporting. The primary customer contact will have a CC Plus license. They will be using the delegated admin feature to manage their users at their company. And the secondary customer contact will be customer community license. They also don't have need for advanced sharing, role hierarchy, or reporting. The role hierarchy on the service side, pretty straightforward. It's just divided into US and Canada. There's no management mentioned relevant for this project, so I just have them reporting to a theoretical CEO. On the sales side, we have a headquarter manager, which is a single role. Beneath that, regional manager. There's 15 of those roles, one per region. And then below that, we have office manager and system specialist. For each of those, there's a role per office. So 150 roles on each of these levels. And then reporting to the system, or owned by the system specialist, will be the primary customer contact, or the customer account. So this primary customer contact role will roll up to the system specialist. This has a separate role per customer account, and it's an external role. Now to the system landscape, starting with how those users will access the new Salesforce system. We'll start with the internal users whose identities are stored in Active Directory. We'll be using IWA so that they can get SSO when they are authenticated into their network. ADFS is what I'm recommending as the IDP. It will support the SP-initiated SAML SSO. They were looking for deep linking functionality, so that will support that. The customers will be using a mobile publisher app and Facebook, Twitter, and LinkedIn to authenticate via social sign-on using the OpenID Connect flow, layered with user agent flow for the app to connect. Or they can just access via browser and Facebook, Twitter, LinkedIn. The contractor will be using a browser and the username and password login to access the experience site. The internal system specialist will be using a Salesforce mobile app, so that will be a user agent flow layered with SAML. The quick note on the mobile apps. For the mobile publisher and on Salesforce mobile app, I went with the simplest app that could meet requirements. There's no custom development required for these types, so it reduces risk of delivery of the project. And given that 4 months is the main goal of this project, we want to minimize those work streams. I did not see any requirement like perfect branding, perfect performance, or real-time location services or background processes that would have pushed me to a hybrid or custom native app. Salesforce itself will have My Domain enabled to support Experience Site and single sign-on. It'll have Service Cloud, Sales Cloud, Service Cloud Voice. App Exchange-wise, it'll have Conga, DocuSign, and SMS Magic. Of course, we'll have the Experience Site, which will be a customer community. Reports and dashboards will be used for operational reporting. I forgot to write it here, but Tableau CRM will be used for the cross-platform reporting or LDV reporting, anything beyond the capability of reports and dashboards. So together, that's our reporting strategy. Salesforce files, due to the number of users, which is about 3,680, we have a roughly 7.3 terabytes of file storage available in Salesforce, and together with an archival strategy that will be sufficient for all of our files needs. We will archive files as soon as projects are delivered or installations are complete and they are no longer needed at that point. They will be archived. More on that later. Integration-wise, we have a website which will connect directly to Salesforce via the web to lead functionality. But we'll also, every other integration besides that and mobile will be going through either the ETL or ESB we'll be introducing. Both of these will connect to Salesforce via the JOT bearer flow and use two-way SSL to encrypt data in transit. ESB will connect using REST and Comet D. ETL will be using bulk. Both of these will be used to decouple systems and avoid point-to-point integrations, and will handle things like protocol conversion, data translations, transactionality, and complex orchestrations across multiple systems. So we can roll back all of them if they have an issue. Keep systems in sync. The ESB will be used more for near real-time small volume interactions that are event-driven, and the ETL will be for periodic or scheduled large volume operations, and such as data migration and archival. So the ETL will be migrating data from the existing CRM, which we'll be replacing with Salesforce and therefore sunsetting, as well as the ERP, and actually some from the monitoring systems as well. I forgot to draw this arrow. We'll be migrating data via the ETL for that too. And then we'll be archiving data from Salesforce using the ETL to the data warehouse for data. ESB will help us integrate with the website, with the monitoring systems, design tool, and ERP. These are all existing systems. The ERP, there's 2. Monitoring systems, there's 3. So the ESB will also come in handy for orchestrating and calling the right systems and handling all that for us. And the devices will feed data directly to the monitoring system. That's existing functionality. ADFS will also be used for SAML SSO into the monitoring system and ERP as mentioned as well. Here, moving on, we'll get to these integrations as we approach them. The data model, just to explain a legend. So all the relationships here ended up being lookups. There's no master details. The skinny black outline is standard objects. The blue is custom, and then the green is, there's only one of those. It's an external object. SS just means system specialist, SR support rep, PCC is primary customer contact, and then P is private, CBP controlled by parent. Those are the org-wide defaults. So every object you can see that on. We will step through this sort of as we go through the scenario. At the beginning, there are 5,000 leads a month. Lead is private, owned by the support rep. It converts into a account and contact pretty quickly after a pre-qualification. Account is private, owned by the system specialist. There's with growth, it'll be about 150,000 accounts, as mentioned here, and then contacts. I'm just guessing or estimating 300,000. It'll be controlled by parent. Account types, we've got contractor and customer here, and then each account has roughly 2 locations, so 300,000 locations. They're private, owned by the primary customer contact. And then there's a sales process here, which will be using a custom object called estimate. I heavily considered using opportunity. However, because the customer and contractor had to be heavily involved in this process and definitely have visibility to this object, I went with a custom estimate object, which will be private, owned by the system specialist, estimating about 3,000 of the 5,000 leads get through to this point. But the important thing to note is, we would have had to give partner community licenses if we used opportunity to all of these users. So over 800,000. I did not think that it was justified, given that we, at this point, are not even using line items, because my assumption is this early in the sales process, we don't even have a bill of materials yet. They're making designs at a high level. Later is when the order object comes into play, is when we actually get a bill of materials using the products and product objects and price books, price book entries. So on to the business requirements in a bit more detail. Starting with the sales and design process, we're using Service Cloud Voice to route phone calls that come in with omnichannel, and we're using a web to lead form for the website in order to intake leads that way. And then we're using lead assignment rules, I should say, for the routing of the web to lead based on I believe it says geography or location information. So next, there's 5,000 of these a month, so that's under the web to lead limit of 500 a day. No concern there. There's a pre-qualification custom questionnaire, which I interpret to be, or I'm recommending a screen flow on the lead to ask that questionnaire over the phone. And then we'll convert the lead at this point. There's then a site visit that needs to be created and assigned to a system specialist. That'll be modeled by the task object here, which will be post-conversion, so that it'll convert into account and contact. And they'll create an estimate at that point as well. And then this will be the task underneath the estimate, which represents the site visit, as you can see, assigned to the system specialist. Volume will be about 3,000 a month on this as well. So what they do during the site visit, they take videos and photos. Those need to be accessible in Salesforce. They create a preliminary estimate, send via email, and then capture GPS location information. So this is where they'll use the Salesforce mobile app. They can upload photos and videos via the files related list on opportunity. My assumption is these are very short videos, which would be under 100 megs, and this is, again, files we can archive once they're no longer needed, which will be later on once the installation is complete. As for the preliminary estimate, so the system specialist will be updating this estimate based on information they gather during the site visit. Forgot to mention, we'll use an LWC to use the geolocation API to get the GPS info from the device and save that to the location. So the task will also have a lookup to this location object. And then, at that point, I'm presuming, since it's just a preliminary estimate, that it's acceptable to just use an email template with some merge fields from this estimate object, since they're not signing it and it's not an official document, it's just informational. So they'll create the estimate, and then this needs to kick off giving the customer access to the experience site in Salesforce, and they need to collaborate. So we'll have a trigger on the estimate creation to enable the existing account and contact as a customer account and contact, and use a queuable Apex to create the user to avoid the mixed EML error. That'll send them the welcome email as well. They create design plans with a custom design tool. They can be over 100 megabytes. They should be accessible in Salesforce. So my assumption here that I stated previously is the design tool can be modified, allow them to manually enter the Salesforce record ID of this estimate, and then initiate the integration to send back the PDF and the record ID that's entered to be able to save it against the estimate in the files related list by inserting a content document with the first published location. So this is kicked off by a button click in the design tool. It's a remote call-in with the REST API. The design tool will call the ESB, which calls the Salesforce REST API. It's a design tool created doc that needs to be visible in Salesforce. That's a justification for this pattern. Once the doc is created, they need to notify the customer. The customer can collaborate and ultimately digitally sign. So the SS user can just chatter @mention the customer that needs to look at it. They can use chatter to collaborate from that point. And then we'd be using Conga for the estimate document generation and DocuSign for the e-signature by the customer. Here that they also provide financial data. The system specialist it records it against the location. And then there's an approval process with a local manager and possibly a regional manager conditionally if the installation cost is high enough. So that'll be a standard out-of-the-box approval process on the financial data object with a conditional step depending on what the data entered is. So here, I haven't mentioned that object yet. So it's related to the location. It's a separate object due to some privacy and sharing functionality. We need to lock it down further than the location. And it'll be private. It'll be owned by the system specialist as well. The volume will be about the same as the location. It should be about a 1-to-1 ratio, I'm assuming. Customers need to use Facebook, LinkedIn, Twitter. So that's social sign-on. They'll set up auth providers for each of these, generate a registration handler, and assign it to each, and then edit the login page to surface these as options. Next phase, contracting and installation. So here's where the contractor comes into the picture. They are created and mastered in ERP and can't be updated or created in Salesforce. So we'll have a validation rule to prevent any accounts of type contractor from being created or edited in Salesforce. The contractors should be sent daily and automatically provisioned for access. So we'll have an integration, a nightly batch from the ETL, which will pick up the new the deltas in the ERP contractor records, and then load them into Salesforce with a batch data sync pattern using the bulk API. Its justification is only needed daily, and it's a large volume operation. From there, there's an Apex trigger on the create of the contractor account in Salesforce to enable it as a customer account, and then use a queuable job to create the user again, to avoid that mixed DML and send the welcome email. Next, the system specialist selects a contractor for the installation. And the customer design docs, estimates, photos, and videos become available. So it mentions installation, and I have an object called installation. I want to preempt any confusion here. Really, this is really still just bringing the contractor into the design phase at this point. We're not actually starting work. So we're actually talking about the estimate object, which will be shared to the contractor at this point. I forgot to draw, but it'll have an additional lookup to the contractor account, and we'll use a sharing set to grant that contractor access to that estimate that they need access to in order to see the related documents in the files related list, the on-site visit, etc. Granting, and that'll grant edit access based on the lookup to the contractor account being the same as the user's account lookup. The contractor reviews and collaborates. Then they revise where needed, and if needed, repeat the approval process. So we'll use Chatter for the collaboration. They can request changes via Chatter. The SS will update the doc, the design doc that is, which would restart the approval process so that those changes can be approved. The contractor indicates acceptance, generate a contracting agreement to sign. So they can indicate acceptance just via checking a checkbox field or via quick action on the estimate. It triggers the Conga document generation, DocuSign e-signature envelope to be sent. The contractor will sign it, and it'll be stored in the files related list. The system specialist is notified of the contractor acceptance and then places the order for the devices, materials, and supplies. So as you can see here, this is where the actual products come into the picture. Once the design has been finalized, they figure out, the system specialist will figure out what products are actually needed to meet this design. So this will be, on the DocuSign envelope status update becoming signed or fully signed. There will be an after save flow, which will Chatter post on the parent's estimate record and mention the system specialist to let them know they're good to go. The order is created in Salesforce. Once it's flagged complete, they need to send that to the ERP. So my assumption here is the system specialist creates the order manually and then builds out the order products related based on the agreed upon design. Mark that order complete, and then that'll kick off another integration where Salesforce will use a fire and forget pattern with after save flow publishing a platform event, which the ESB will subscribe to, call into the ERP to create the order. There's no need for an immediate reply. That's why we're using, or confirmation. That's why we're using fire and forget. But I am recommending we receive a response from the ERP, and then the ESB will call back into Salesforce via remote call-in via the REST API to update the Salesforce order with the ERP details. So the reason we're doing that is this requirement saying the detailed order data from ERP needs to be viewable from within Salesforce. Next, when the ERP then sort of becomes the system that manages the order, it needs to send updates to Salesforce. So we'll have another integration where anytime the order status is updated in ERP, ERP calls the ESB, which remote call in to Salesforce REST API to update the order status for the corresponding Salesforce order. We'll have the ERP store the Salesforce orders Salesforce ID via the previous integration. The reason we're using remote calling here, it's near real-time, small volume, and externally initiated. Once the order arrives, then the system specialist and contractor need to be notified by SMS and email. The the integration we just talked about will update the status to arrived. We'll have an after save flow to send the email, SMS, use SMS magic to send the SMS to the system specialist and contractor. So during the actual installation, when devices are added, they get automatically connected to the appropriate monitoring system here, shown here. And then they need that to automatically create a record in Salesforce for the device and associate it to the location. So we'll need an integration here. Later, it's mentioned that this system can initiate integrations. So we'll have the monitoring system call the ESB, which will remote call in the Salesforce REST API to create an asset when the device is added in the monitoring system. And my assumption here is that the device can pass the GPS coordinates it has to the monitoring system, which can then be passed as part of this integration. And we can have a trigger on the create of an asset, which queries the location record with the closest distance and associate the asset to that location so that it ultimately has is associated to the right customer account. We'll also be saving the stringified barcode. Each device is going to have a barcode, and it'll come into play later more, but we'll have this stringified barcode saved within Salesforce as well, which is done by this integration. I assume the stringified barcode is device metadata that's available. So once the install is final, Salesforce is updated by the system specialist, and there's a creation of an invoice in ERP. So Salesforce is going to have a fire and forget pattern after save flow, platform event publish, ESB subscribe, call into ERP, create the invoice. There's no need for immediate reply or confirmation. That's why we're using fire and forget. Quickly to recap, that was the order process and the installation. Order and installation are both private objects owned by the system specialist. Installation, guessing the volume should match locations. That seemed like a one-to-one. So 300,000 there. Moving on to scheduled maintenance process. So the maintenance schedule is set by the system specialist when the install is complete. So they'll create this record in this custom object called maintenance schedule. The system specialist will create it and then pass it to the support rep. As is mentioned here, it's managed by the support center after installation. Each customer location is serviced twice a year. So I assume one maintenance schedule per installation. Two scheduled, these will be modeled as work orders. So that would be 600,000 scheduled work orders per year based on this. We can archive work orders after they are complete. When it's 1 week away, they need to create the service order in the ERP. We'll have scheduled Apex nightly to query maintenance schedules where the next maintenance date, which is a field on it, is today plus 7 days, basically, and then create the work order at that time, but with a date that is 7 days in the future. And then we'll also have an integration here because the ERP needs to know about this. So when the work order is created or also completed in Salesforce, we'll have, again, fire and forget with the after save flow and platform event, ESB subscribes, call into ERP, same pattern as the last one, but it upserts a service order in ERP, and again we'll pass the ID to link them together. Next, the system specialist updates on their mobile device. It needs to be updated on a real-time basis, so that's why we're reusing this for when it's completed or updated as well. And the app they'll be using is still the Salesforce mobile app, same one as with the site visit. Last process, monitoring and issue management. So there's 3 ways that these issues can be created. There's first way is via the monitoring system intelligent connection. This first bullet is just continuing to monitoring system will continue to perform emergency services. So Salesforce doesn't need to worry about that. We don't need to build anything. There's the system can make real-time API calls, as mentioned. So they need Salesforce to be updated with when certain events are raised. So we have another integration here. Monitoring system receives an error event, let's say. It will call the ESB, which will remote call in the Salesforce REST API to create a case. This is near real-time, small volume, and externally initiated. Next, the case will have the type of case will be device created. They also need to have a task created underneath the case. So we can just do that within Salesforce by having an after save flow on that case type to create an associated task to call the customer. The issues can also be raised by the customer contacts. So they can do this via web or mobile. They'll have access to the experience site, a mobile publisher app, and the contact support component to raise cases. They do need to be able to photograph the barcode and identify and sort of link that case then to an asset in Salesforce. So they'll take this picture with the mobile publisher app with a Lightning Web component that has, or they'll upload it with a Lightning Web component that has a JavaScript library to convert the barcode image to the tokenized string, query the asset that has that string on it, and associate it to the case that's being created, or associate the case to that asset. Issues, so they need to route based on geography and expertise. That'll be a case assignment rule to a geography-based queue, and then skill-based routing based on the expertise. Want to quickly catch up on the data model. So we have case here that's private, owned by the support rep. 6 million a year is the expected volume. We'll see that in a minute. And then we'll be using skill-based routing with the skill required. There's several other objects here. I didn't have room to draw them, but they represent skill-based routing. Next, there's a maintenance task. Can create a service order in ERP if maintenance or repair is needed. And the ERP needs to give immediate feedback of success or failure. So we'll provide a screen flow to create the work order in this case if it fits this use case. Salesforce will use a request and reply pattern this time with flow and external services because they need that immediate feedback of success or failure. And of course, we'll be going through the ESB to the ERP. Next, issues can also be put in by internal employees so that customers can call and the support reps can create the issues manually. The profile will have create case permissions. From this point, everything is already been covered. Last point here, the volume. So each location will produce an average of 20 issues per year. That's how we got to 6 million cases based on 300,000 locations. They need to be tracked, and about half of those will also require a work order for the unscheduled maintenance. So that's 6 million cases, 3 million work orders of the type unscheduled maintenance. So altogether with the scheduled work orders, that's 3.6 million a year. That's a large data volume. We'll archive cases, work orders, and also these tasks, which I think I forgot to mention. Oh, no, I did mention. But anyway, these are all transactional. They can be archived after they're closed. task I just have on here twice because this was the site visit and this is the calling the customer. They're handled by two different people for two different use cases. That's the same object though. So quickly, a note on the data volume. So case task work order, as I said, can just be archived before we get into the millions of records at any given time. So I don't expect performance issues there. Asset is the one object with a true large data volume that we cannot avoid. It's also not, it doesn't count against storage, which is good for us. You can't use skinny tables with it, which takes one tool out of our tool belt, but our approach will be to use selective queries whenever possible for list views and reports, leveraging standard indexes and keeping the volumes only returning the minimum number of fields required. We'll also, if we have to filter on other non-index fields, we can contact Salesforce to create a custom index for that. We'll also archive these as soon as they go out of service or no longer needed operationally for service. Data migration, so we need 5 years of leads from CRM, but the ERP will essentially win if they're already existing as an account and contact in ERP. So that sort of helps us know how to handle duplicates and merging. ERP, we need all customers, locations, and contacts. The ERP systems will also have the sales and service orders, and we need to be able to logically link all these records between Salesforce and ERP. And then the the monitoring systems have the devices which need to be replicated in Salesforce and also logically linked. We'll do that via the stringified barcode and perhaps also a serial number. And then the design docs are just sort of all over people's desktops. I'll talk about that approach. So the ERP, my assumption is we're going to have all these objects coming from ERP for in-flight deals and installations. I assume we'll have data in all these objects. It's account, contact, location, estimate, order product, installation, maintenance schedule, and work order. CRM will have the leads for the last 5 years. Monitoring system has the assets. Keep in mind there's 3 monitoring systems and 2 ERPs, so we'll have lots of deduplication, merge, and enrichment type of logic with ETL scripts. And then the desktop computers will designate a central shared drive to collect these documents. To note, it's only the design docs for open orders, which greatly reduces the volume that we need to worry about. We create the shared drive, and then we'll have a naming convention where it's named after the ERP's order ID, or it will have that in the name so that we're able to link it to the appropriate Salesforce record based on that unique identifier. ETL will extract all of this data and dump it into first a staging raw source format database, and then we'll standardize, cleanse, dedupe among these 3 monitoring systems in ERP, and also for the CRM and ERP for conflicting leads and accounts and contacts. And we'll enrich that data as well if we can. We'll work with the business to define how that logic will work. We'll transform the shape of that data with ETL scripts to match the Salesforce schema format. We'll sort it by parent ID to minimize lock contention risk, sequence as I mentioned, and then we'll use external IDs for a dual purpose here to maintain the relationships among the data elements that we'll be loading into Salesforce, but also to maintain the linkage between the Salesforce records and the corresponding ERP and monitoring system records as well. Non-operational data will go straight to a data warehouse for archival. So that would be things like leads older than 5 years, orders older than 3 years, and also inactive devices or customers, those sorts of things, installations that are already complete, those sorts of things. We'll use the Bulk API 2.0 with parallel mode to load into Salesforce, first into a Dev Pro, then into a partial, then into a full sandbox, and then into production. with increasing volumes. We'll deactivate automations and validations prior to loading. We'd also defer sharing and activate parallel sharing recalculation and granular locking. We then load the data, then reactivate the automations, validations, resume and recalculate the sharing, and then of course, sanity test and make sure that we met our acceptance criteria for this data migration. Onto visibility and accessibility. System specialists need to view all the customer and installed system data for their own customers. That's just ownership. They need the same thing for other specialist customers in their local office. So that'll be an owner-based sharing rule per system specialist role, which is a total of 150 sharing rules. On account and also installation, granting read access to the members of the owner's role. We'd have no sharing rule on financial data. The managers need access to their areas, including the financial data. They'll get that via the role hierarchy from the system specialist. Contractors are able to edit the data only for their own, for the customer locations they've been assigned, except for the financial data, which they can't access. So location is going to have a lookup to contractor account. I forgot to draw that. So it actually has two lookups to account, one customer, one contractor. And we can use a sharing set granting edit access to the contractor based on that shared account lookup. My assumption here is only one contractor at a time works on one location. Customer contacts should be able to edit their own customer contact and installed system data. So the org-wide default will be private for account and installation. There'll be a sharing set on account where the ID is the user's account, just to raise their access from a read to edit. The contact will be controlled by parents, so they'll get access to that. Sharing set also on installation, where the installation's locations account is the user's account, and granting edit access there. There's this customers with the account hierarchy. Primary need to be able to see location and subordinate data. We can fulfill this with external account hierarchy, which will sort of make the lower accounts roles roll up to the top role in each higher account. My assumption by what is meant by subordinate data here is means accounts and locations for the accounts that are lower in the hierarchy. Support center representatives need to see all the data in their geography, except for the financial data. So each object with an org-wide default private, I'm not going to list them all here, but they need to have a geography field, which will say US or Canada. And they also need two criteria-based sharing rules, one for each, to support to share the records to support reps US or Canada with read access. I forgot to mention here the historical work order is also going to be an external object. That's the work orders get archived to the data warehouse and then surfaced here as reference data and via the historical work order object. I think I forgot to mention asset will be private, owned by the system specialist. There's 30 million of those. Reporting, support reps and managers and system specialists need to report on sales activity and schedules. So that's just Salesforce reports on operational data. They also need to report on the number of device monitoring events. So I assume that this is referring to only the events that end up creating cases. So that'll just be a Salesforce case report. Managers have ad hoc trending, showing a lot of types of information sliced and diced, including monitoring system activity. So Tableau CRM is my recommendation for cross-platform LDV reporting. Customer contacts need to show issues, reports showing issues of their statuses for what they have access to. This can be achieved with a case list view. It doesn't mandate a higher license for reporting. Report can be run live from the public website, showing the number of events and installations for the US and Canada. So I'm recommending they just use a web component in the website and an integration to retrieve that data in real time, which can call the ESB, which calls Salesforce to get the count of the installations via the remote call-in REST API. And then they can call each of the three monitoring systems to total up the number of total events. My at least that's my interpretation, is they're interested in all events for that one. Project and development, English and French. We'll use Activate multi-language using the translation workbench for standard UI, custom labels for custom UI, VF email templates for emails, and then we'll surface the language selector component in the experience site for multi-language communities. And I think I just ran out of time. Should I continue or should we wrap here?
I think you should wrap it.
We're stopping. Yeah, we're stopping.
Okay.